Hello children, welcome to channel Sube. Today I am going to discuss question number 20 of 2019 Physics MCQ new syllabus paper. A coil is made by winding capital N number of turns around a plastic ring of mean radius capital R and cross-sectional area capital A as shown in the figure. This coil is placed coaxially with a long straight wire carrying a current simple I. If the rate of change of current through the straight wire is I0 cos omega t, which of the following expressions gives the electromotive force EMF induced in the coil? So there are 5 answers. Children, how do we calculate electromotive force induced in a coil? So we have to go to Faraday's theory, Faraday's equation. Electromotive force E equals minus d phi divided by dt. This phi is the flux linked. So we don't have to write this minus sign. We can neglect it because they don't ask about current, so we don't have to apply Lenz's law. So we can write just d phi divided by dt. Furthermore, the most simple way, just we can write phi divided by t. This phi is total flux through the coil. So we have to find out the total flux. The straight wire carrying current I like this, because this diagram is a 3D diagram, so you might have trouble to understand it. Therefore, you learn normally in the classroom drawing a picture like this. You just draw a line, and we say the line is infinite, so you draw some dots here like this, and perpendicular to the line the flux density you learn. If the current is this way, I, the cross is here, so B you learn equals flux density equals to μ₀ I divided by 2 phi d. So this distance is d. So normally this is what we learn in the classroom. So the same thing is here in 3D model. What you need is the flux through this coil. When the current passes like this, the flux is distributed like rings around the coil like this, like this. Like this. Closer to the wire, the flux density is thicker. That means they are very close to each other like this, very close to each other. When they go away from the wire, they become less dense like that. So just 2 is enough. The wire is before the flux lines. The current, say I. So the direction of flux lines this way or this way. You know the method how to find out it using your right hand. So the current is this way, the flux is this way. That doesn't matter, it doesn't influence the answer. Somehow you might get questions in future exams, that's why I paid attention to that. So the coil is like this. Coil means this turns. This turns. Turns means some people can't understand, some student can't understand what is this. So I have to explain a little bit that also. There is a plastic ring like this. There is a plastic ring, just a plastic ring like this. Plastic ring that is drawn in 3D form. So coil is wound. Coil is wound around like this. Coil is wound around this. That means like this we wind it. So that is how this diagram is drawn. So a particular turn I draw like this. What is this black color line? The copper wire. Copper wire means the coil. What is the difference between coil and just a wire? It is insulated by a certain material. It is like a paint. So that wire is that special wire is called coil, not just copper wire. So the wire is like this, but actually wire is not closed like this. Wire is actually not like this. The front and the end and the beginning of the wire is looped to the early coil like this. Like this. The end of this wire is looped to, connected to the next loop like this. This is how it runs around this plastic ring. I think you understood now well. But it doesn't matter, we can draw it as a closed loop like this. Like this. So the surface of the turn, I have to use another color, is this. So the flux lines penetrate through this surface like this. That is what we call linked flux. We have to take into account not just flux, linked flux. So only we take into account what are the flux lines go through perpendicular to this surface. We don't consider other flux lines, just penetrate through this surface. So they have given this surface of a turn as capital A. So we have to remember the equation here which gives flux density B. If we don't know flux density, we can't find the answer. The flux density of at a point away from distance r from the straight wire, that is what we learn in the lesson like this, μ₀I divided by 2 pi d. So here the same thing, but the diagram is 3D. μ₀I divided by 2 phi the distance is r here, therefore we write r. So this is only the flux for 1 square meter, but there are number of lines like this. I have drawn only 3 lines. There are infinite number of lines. Therefore we have to calculate the total flux through this capital A area. So just the flux through this one what they call ring, one ring, sometimes we say loop, they call this one ring. Through one ring flux is B times capital A, since the area is A. So this is the flux through one ring. There are n number of rings like this, all perpendicular to the flux. Therefore total flux, what we need is, so total flux is what? N times B A n times. So now we know total flux, B times A times n. So now we can substitute it here. E equals B times A times n divided by T. Now we have to use what they have given, I naught cos omega t. What is that? Rate of change of current. If we say rate, the word rate, that means divide by t, divide by time. So rate of current, current means I divide by t. Rate, if we say rate, the denominator must be time. So I divide by t is given I naught cos omega t. So we can use it. So to use this, before that we have to substitute the equation we have written for B. What is B? B is this one. B is this one. So let us substitute it here. B here. We can say but B equals this one. So E equals mu naught I divided by 2 phi r, then A n t. A n divided by t. What we did, instead of this B, we substituted this one. Then they have given I divided by t. So here I, here t. We can rearrange the equation. I here, 2 phi r, t here. So this thing they have given. Then mu naught A n divided by 2 phi r, I divided by t, they have given I naught cos omega t. This is the final equation, electromotive force. So we have to select the answer for this one. So children, I think you understood. I tried well so that you can understand it. So thank you very much for watching my videos. If you are happy about my teaching, please subscribe my channel. See you tomorrow. Goodbye.